Okay, let us discuss question number 2.55. So you see, in the last problem what we have done is, we have been given equation of process. So process equation is given, and then you have to find value of C. Now this time reverse, we have C is given and we have to find equation of process. So we have to find an equation. You're getting? So this time we have to find the process equation. Let us say question says, for the case an ideal gas, again the situation is ideal. So gases are ideal. So I can apply PV is equals to nRT. So this says for the case of an ideal gas, find the equation of process in variable T and B. So we have to find equation in T as a function of temperature and volume. So as a function of temperature, volume both are right, you can have either one only. With the molar heat capacity varies as. So first part of the question, C is given as Cv plus alpha T, and then we have to find the equation of process. So what we will do is, we will do again, C is written as dqy and dt. Did you remember or not? And our dq is du plus dw by n dt. dw can be written as pdv, so du plus pdv divided by n dt. So your C will be, and du is n cv dt by n dt plus pdv. So what you will have? You will have n dt goes, so cv plus pdv divided by n dt. Are you getting? Now let us equate this C with the given C. So given C is Cv plus alpha T. So equate this. So Cv plus alpha T is equals to, now we have been given this and I am getting this. So Cv plus pdv divided by n into dt. Now Cv goes, so I will have alpha T is equals to pdv by n dt. Now I want to do integration so that I can get the equation of process. But only thing is, I have temperature this side I can take, okay, but this pressure is not there. So what I can do is, I can apply ideal gas equation to eliminate pressure. So I have PV is equals to nRT, so this means P is equals to nRT by V. So if I put this here, P is equals to nRT by V, so I will have alpha T is equals to nRT by V into n dt, and up you will have dv. I think all of you are able to understand. So n goes out, this T also goes out, so you will have a very simple relationship, alpha by r dt is equals to dv by v. Are you getting or not? Now I can do integration both sides. Let us do a indefinite integration. So I will have alpha by r t dv by v, so ln v plus some constant k. Are you getting or not? So this is the equation of process. If you want, you can also write in the other form the same equation in exponential form also. So what you can write is alpha by r to t ln v. This is a constant, so I can also write ln some constant k dash and ln a plus b. So I can write ln v plus constant can also be written as in the form of ln. So in that case, a plus b is ln k dash into v is equals to alpha by r into t. And from there I can write in exponential form. So k dash into v is equals to e to the power alpha t by r. Are you getting? So you will have v is equals to 1 by k dash e to the power alpha t by r. Are you getting? So 1 by k dash is again a new constant, so I can write equation in another way also. I can write, let us say v is equals to 1 by k dash e to the power alpha t by r, or let us say if I take this that side, so I will have v into e to the power minus alpha t by r, I think all of you are getting, is equals to 1 by k dash, and 1 by k dash I can write another constant, so let us say k2, or let us simply call constant c. So this is b into e to the power minus alpha t by r is equals to constant. C is basically constant. So this is the equation of process. Be a B part of the question of the same question, same kind of thing. So I think all of you have copied this one. If you have missed something on the top, let us copy fast. So let us go for the next. So B part of the question says, now this time the equation of process is C is given by Cv plus beta times B. Now again I will equate with the C. In the first part I have already calculated the expression for C. You see here, I have expression for C is Cv plus PdV by n dt. Are you getting? C is equals to Cv plus PdV divided by n dt. I will use the same thing. So C is Cv plus PdV divided by n dt. Now equate the given C is Cv plus beta V. So this is Cv plus beta V is equals to Cv plus PdV divided by n dt. Are you getting? So Cv goes out. So we will have beta V is equals to PdV by n dt. Now I want to integrate V and T, so I have to integrate P again. So P is nRT by V. So if I use that, I'm getting on P is equals to nRT by V. If I plug this thing, P is equals to nRT by V, we will have beta V is equals to nRT by V into dV by n dt. Are you getting? So dV by n into dt. So this n goes out, and you will have, this is beta V square, and this is equals to R T dV by dt. Now again you can integrate. So let us take beta by R as constant, and you will have dt by t, and here you will have dV by V square. Now let us do indefinite integration. So we will have beta by R ln t is equals to 1 by V square is minus 1 by V. I think all of you are getting this one. So I can write some constant also. So let us say some constant. I can write this constant K. Further I can modify this constant. So ln t is equals to minus R by beta V plus Rk by beta. R is constant, K is constant, so this all are constants. So I can put this as a constant. Let us put this constant as ln k dash minus ln k dash. So if you take this side, let us put this constant as a constant ln k dash. Why I am doing this, you can understand soon. Ln k dash. Now k dash come this side, so will be minus. So we will have ln t by k dash is equals to minus R by beta V. Now this is simply mathematics. Now if you want, you can take this as e to the power. So if you want, you can write the same thing in as an exponential form. So if you turn this into the exponential form, what you will have, I think all of you copied this one, t by k dash. So you will have t by k dash is equals to e to the power minus r by beta v. Now you can write t is equals to k dash times e to the power minus r by beta v. So this will be the equation. If you want to write this side, so we will have t e to the power r by beta v is equals to some constant k dash, that is a constant. So your equation will be t into e to the power r by beta v, this is equals to constant. So this is the equation of process. We also have third part of the same question, and in the C part the question says, so in the C part question says beta C varies with Cv plus Ap. So first time it varies with temperature, you see. First time C varies with as a function of temperature here. Second time you see C varies as a function of pressure. So this is given to you. C is Cv plus beta v. So this is a function of volume. In the first part also this is a function of temperature. Now this is a function of pressure. So C is Cv plus Ap. That's a function of pressure, you see. So linearly varying. So C linearly varies with pressure. First part C linearly varies with temperature, C linearly varies with volume, C linearly varies with pressure. So we have three parts. In the first part we have said C varies, and basically this variation is linear with temperature. Second part C varies with pressure, volume. Third part we have C varies with pressure, and these all variations are linear in nature. And these three cases basically we have to find out the equation of process. Are you getting? I think you can do this part yourself. Let me wait for 1 minute time. How many of you can do this part your own? If you are able to do this one, then it's fine. If you are not able to do this one, then there is some problem. You have to gear up yourself. So let us do this one. Okay, let us discuss. So you see we have calculated C. C is given by Cv plus PdV by n dt. So I will use that fact. C is given by Cv plus PdV by n dt, and I will equate this with Cv plus AP. So Cv goes out, and now this time I want to integrate and dt equals to AP. This is AP or alpha P? Let me check. This is AP. AP. Now I want to integrate. Basically this P goes out. So this side AP, this side AP. So this is simple. So if you cancel this P, so this is a one line question. So this is dV is equals to a into n into dt. Are you getting or not? So you simply integrate this because n is constant. So dv is b plus a n t and some constant k. Are you getting or not? So you can say b minus a n t. So b minus a n t is equals to some constant k. So this is the equation of process we will have. B minus a n t is equals to constant. If you write for n mole, you can write for 1 mole equation if you write for 1 mole, because the answer gives answer for 1 mole. So for 1 mole if you write, equation will be B minus AT is equals to constant. Are you getting or not? So this is the required equation you will have. I think all of you have copied this one. So this problem is basically pretty easy problem, only mathematics. There is no physics involved in this question. And these kind of questions are generally very few times have been asked in G. Of course, 1 or 2 times they have asked this question. But this is more mathematics, less physics. In one kind of question you have been given process and you have to find heat capacity. In other kind of question, that is reverse is true. You have been given heat capacity and you have to find equation of process. For EG, we have made the equation of process heat capacity as a linear variation. And that's why CV cancels out, so integration becomes easy. Are you getting or not? So you have been given 3 conditions. You have been given 3 parts in which heat capacity varies linearly. In the first part it varies with pressure, second part temperature, third part with volume, and then you have to simply integrate. So if you have a linear variation, that's fine, mathematics becomes simple. If you have some parabolic variation or some exponential variation, logarithmic variation, maybe mathematics becomes difficult in those cases. We'll discuss the next problem.